So with regard to this particular problem, let's see. So they give you this generic, wow, what am I doing over there with my hand? So evidently there's not a hand rest going on here. And I don't know how to erase. So that's interesting. How do you erase? Is it that? No, that's the highlighter. And that's the pen. And I thought that was the eraser. And it is the eraser. Let's go with the undo button. All right. So we're not going to edit that. Let's do this pen thing. And so this guy right here is your generic equation or function. And they inform you with these, 7 data points that you have a 0.1 comma, 2000 comma 1.0. But in fact, with this information here, t equals 0 corresponds to the year 2000. This is actually incorrect. You need to be using 0 comma 1. And for instance, then 0.2 is 2 comma 0.93, etc. So you're supposed to use this data, this information, to determine what the equation is for the function is that governs this data. So there are a couple things that we know that we do not, quote, know, and that would be y sub 0 and the base for this function. So let's first use this first data point with an x value of 0, or technically a t value for 0, to determine the first thing. So when they tell you with this point that when t equals 0, year 2000, f of t is equal to 1. So f of t is equal to 1 when t is equal to 0. So I'm just basically going to substitute those values in. And so t is equal to 0. But as we know, when any base is raised to the exponent of 0, we get a power that's equal to 1. So this equation can be simplified to be 1 equals y sub 0 times the number 1. y0 times 1 is y0. And so this should tell us that y sub 0 is equal to 1. And that's going to be for all situations. Yeah, it was 0.93 right here. So if y sub 0 is equal to 1, our new generic equation now looks like this. F of t is equal to 1 times b raised to the t, which is simplified to be b raised to the t. Now we need to go back and grab one of those other points. What was one of the other ones? 2 comma 0.9, I want to say it was 3. Might have been 8. Let's go back and look. And so that's a second point. We can take the second point and substitute it in. So f of t is 0.93 when b is equal to 2. Now, to determine what the base is for this function, how would we take this equation and solve for b? Hopefully you're saying we take the square root of both sides, and we get 0.93 equals the base because we took the square root of both sides. Let's use a different color and kind of point that out up here. Okay? And so we get b is equal to that. So now the equation that governs this data is actually f of t is equal to, the base is the square root of 0.93, all of that raised to the t. So the second part of the problem asks, oh, I don't have the second part of the problem here. Oh, poopy face. Come on, computer. All right. So the program's going to want you to take the square root of 0.93 and actually calculate that and get a single decimal value, and ask you to round it to 3 decimal places. According to the computer, the answer was this, though I don't think I got that when I put it in the calculator. So your final answer for this part of the problem is 0.966 raised to the t. So that should go in the first box. The second problem the second part of the problem, part B, is asking what is the purchasing power in 2015 will be. So in 2015, they're asking what the purchasing power, which is f of t. So basically what they're asking for, what is the value of the function when t is equal to 15? And so all you do is substitute 15 into that equation for t and put that in your calculator. You should be able to find a power function x to the n on your calculator. And then the third part then is asking the same sort of question, but for the year 2018. So they're really asking for f of 18. So f when t is equal to 18 is equal to 0.966 raised to the exponent 18. So that would go in your calculator as well. I don't have one of those calculators with me, or else I'd talk you through it. So that would be how to do that sort of problem. Okay, so I forgot there was a last part there that I missed. So just as an add-on for this portion to put in your calculator, you're going to enter 0.966, of course, and I think I know why, but I sorted it out. I came up with the calculator this value instead of 0.966. I came up with 0.964. It has to do with rounding in a different direction than the problem, whoever made the problem. But of course, if you calculate the same value that I would calculate, and I would check everything, if you put in 964 and get the problem wrong, I will give you credit, of course. But the computer is accepting 0.966, and you would enter that into your calculator with the caret and raise that to the 18. And the answer for this portion was 0.54. I think that's dollars, or you could say 54 cents if you wanted to. And then the very last part of this problem is they ask you in what year, they don't ask it exactly this language, but it's close, in what year will purchasing power reach, my cursive is not that good, and I'm holding my tablet because I'm doing this video on a tablet, so I'm trying something new, will reach 35 cents, which is $0.35. In what year will it reach blah, 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 35 cents. Okay, so that's a question. And so when we answer that question, essentially they're asking for the output, the y value. So you're going to put 0.35 in for f of t is equal to 0.35 equals the base, which was 0.966 raised to the t. So this is exactly the scenario that we run into when logarithms become very useful to us. So it's really difficult. You do a whole lot of guessing and checking by substituting values in for t to figure out when this equation would actually be a true statement. But with logarithms, I can take the log, or the natural log if you prefer, of base 0.966. I guess then it wouldn't be natural log because it's a different base. So log 0.966 of the value 0.35 to figure out what that exponent is. And even this is kind of painful because this is not a base that's going to be easily taken care of in your calculator. But there are two bases in your calculator that are treated very well. And so we're going to use the change of base formula to change this to a log base 10. So we're going to go log of base 10 of 0.35 divided by log base 10 of 0.966, the above base, the base prior to conversion. And then we put this value, change colors, we put this value into our calculator and divide it by this value from our calculator, and we'll get some other value. And if you give me 12 seconds, I dug up the calculator when I shut this off last time, and maybe it's going to be more than 12 seconds. But anyway, so log of 0.35, close paren, divided by log of 0.966, close paren, and we get an answer that's 30.349, yada, yada, yada. And so that equates to the year 2030. And of course, this 0.349 is just, March or April of that year. So it's going to be in this year that the purchasing power of the dollar drops down to 35 cents. All right? So hopefully that's helpful.